Hello, everybody. I am back on. I'm going to do a quick little overview on polynomial quadratic functions. So, I am doing a little quadratic function overview just so that we understand the presence of why we doing factoring, why we're also doing the box method, and understand what's the process out of this. So the very first thing I'm going to tell you is quadratic standard form is the very first one that I'm going to look at. So quadratic standard form, see, here we are, looks like this. And this looks like f of x equals ax squared plus bx plus c. So why is this a quadratic function? This is a quadratic function because it's to the power of 2. Okay, right here. And this is the most important format of the function because we get to know a lot of its features from here. So a quadratic function is a parabola. So when I look at this value here, this particular version will give me a lot of information. So, hi Vale, miss you guys. So this guy right here, my leading coefficient here, so this is my leading coefficient A. Tells me something about the concavity. So the leading coefficient tells me concavity. What does concavity mean? So a quadratic function is a parabola, and a parabola can either be concave up, like that, concave up, or concave down. So let's talk about this. If A is greater than 1, this right here, so A has to be greater than or equal to 1, then my parabola will go up, concave up, which means it'll open up. If A is less than 0 or negative, then my parabola will open downwards. So that value is really important. The next value that is also very important is here, my constant. And my constant here is going to tell me something about the y-intercept. So it tells me my y-intercept, which in this case we call f of 0. Because when I let 0 here, this guy has a 0 multiplied by a, whatever, that's a 0 plus 0 here as well. So f of 0 will equal c. That's going to be my y-intercept. So far that's quadratic standard form. I'm going to move on to my next format. Here I go with quadratic factored form. Let me just make sure. I'll erase that. So quadratic factored form. Cool. So the next form I have is called quadratic factored form. And if you saw my factoring method video, it's because this one looks like this. F of x equals x minus r1 and x minus r2. Cool. And so what this guy here gives us is it gives me two roots. So this gives me the following information. F of r1 will give me 0, and f of r2 will give me 0. Why? Because these guys are called my roots. These are roots right here. These guy and this guy here are called roots or zeros because they're the x-intercept of the parabola. So if I have a parabola, quick little thing. Bloop, bloop, bloop. Jay, hi babe, how are you? Miss you guys. This is a quick little overview for you guys, so this will do you good. Let's say I have a parabola right here, bloop, 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 like this, right? And this parabola has that's a -2, that's a +2, and we'll call this right here -4. So that's going to be my example. Now, because these are my zeros, I know that I have, for this one, I have f of x is equal to x plus 2. Remember, there's a minus here, so it's always going to be a difference analysis. So this right here pertains to this R1 is this R1 right there. And then over here, x minus 2, that's this second root here, right here. That guy right there is R2. Why? Because remember, these are telling me something about that the x-intercepts, right? So it's always going to be opposite because of that difference analysis. But I'm going to come back to this one just to showcase. So you can have the same function being expressed in standard form and factored form. Standard form gave us insight on concavity if it opens up or down, and factored form is giving us insight on the roots, the x-intercepts of the function. Okay, and so now I'm going to go to the next format. There's one more format, and this is the new one, and I'm going to go ahead and showcase that. And the next format is called vertex form. And vertex form looks like this. Okay, and this is really important because this right here is the vertex. It's either the lowest point if my parabola is opening up or my highest point if my parabola is opening down. So my vertex, f of h equals k. Now notice again, there's a subtraction here. There's a difference analysis with my x variable, or the input for the vertex. So notice in my formula, there's a minus h, but in my vertex, it's just h. So you need to always remember that it's always opposite of what the equation tells me, but it's just for the input. The output is face value. It's as is, okay? In order for us to understand vertex form, though, we must know how to complete the square. So I'm going to go ahead and show a little function, and we're going to go ahead and see what this function tells us. So I'm going to go ahead and start with a function. So bloop, bloop, bloop. I'm going to showcase now completing the square. So this is really important. This is another method. So let's just get an overview of methods. We use the box method. Okay. The box method is used to turn factored form to standard form. Okay, and I'll give you an example. Let's say I have a function. This is my function right here. This is in factored form. Hence, there's two factors. I want to see what this is in standard form. So here I go. Put it into my box. So I have x squared minus 1x plus 2x minus 2. So when I add this all up, I get f of x equals x squared. Negative 1 plus 2 gives me 1x minus 2. So I went from factored form to standard form by using the box. Yes? Okay. So that's the box method. Now I'm going to go ahead and use the backwards box and the little game that we played to showcase factoring. So what does factoring do now? So we use factoring to take standard form and turn it to factored form. Yeah? So, let's see. I'll use an example would be, let's say I have x squared minus 15x minus 56, and I want to turn it into factored form. Well, I do know that a is equal to 1, b is equal to negative 15, c is equal to negative 56. I must play that game, b plus ac dot, I always label. So what's my b? Negative 15. 1 times negative 56 gives me negative 56. Actually, I'm going to make that a positive 56. Okay, so that's a positive 56. So two numbers that I can add up that give me negative 15, but when I multiply them gives me positive 56. If you said, negative 8 and negative 7, let's see. Negative 8 plus negative 7 gives me negative 15, check. Negative 8 times negative 7 gives me 56, check. Here comes the backwards box. Please don't stop here. You must showcase the backwards box because it allows you to validate your work. So this guy right here goes right here, x squared. This guy right here, plus 56, goes there. Remember that these guys have the variable of b, so negative 8x, negative 7x. When I factor it, I get the following. So this turns to x minus 8 and x minus 7. So I went from standard form to factored form. Cool. And right now I'm going to showcase, I'm going to showcase the next process. It's going to turn standard form into vertex form. And that's with, there we go, completing the square. So again, completing the square takes standard form and turns it into vertex form. And this is really important because vertex form gives me the vertex, the absolute minimum or absolute maximum of the function, depending where I'm looking at. So we're going to go ahead and do a problem so you can see how this process works. So I'm going to take x squared plus 16x minus 57 equals 0. Okay, so right now I have this function. So the very first thing I must do, I'm not going to write my little steps that I normally do because you can hear me, you can rewind the video, but please write down these steps. Number one thing, when I'm trying to use completing the square method, I must make sure that my a is equal to 1. If this a is not 1, in fact, I'm going to do another example in a little bit, I must make sure that this looks like a equals 1, okay? The next thing I'm going to do is I only want the ax squared and the bx on this left side. All other values that are constants must be on the right side. So right now I see ax squared plus bx plus c, but I only want ax squared plus bx stuff on the left. I need to move stuff to the right. So I'm going to take this 57 and I'm going to add him over here. Okay? Okay, so far I took and I moved over my c. So I have x squared plus 16x is equal to 57. Now notice that I left a space there. And because I have an equal sign, whatever I do to the left, I must also do to the right to maintain and respect that equality. Okay, so here's where my box comes back into play. So I need to make a perfect box. This left side needs to be a perfect box. So watch what I'm going to do. Dun, 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 dun. This has to be a perfect box. So, of course, this guy goes here. So this is your ax squared. Okay, so x squared goes here. Now this guy right here must be these two things right here must add up to 16x. However, they must be identical. Again, this is the most important step. These two things here must be identical and they must add up to 16x. So something plus something and they must be identical must add up to 16x. What would that be? What do you think that is? Give you some thought process time. So if you said 8x plus 8x gives me 16, you are correct. These two must be identical and they must add up to this value here. Okay? Okay. So now let's go ahead and see what that gives us. What do these guys have in common? These guys have an x in common. Awesome. X times what gives me x squared? X. Awesome. X times what gives me positive 8x? Positive 8. X times what gives me positive 8x? Positive 8. Okay. So now, what do these two guys have? That gives me 8 times 8 gives me positive 64. So I have a 64 that I add here. Notice I already put the plus. And whatever I do to the left, I must do to the right. So there I am. So now, notice that I have x plus 8 and x plus 8. Well, x plus 8, put it over here, and x plus 8 is really just x plus 8 squared. Yeah? So now, I hope you can see that. Remember, again, you can rewind this video, you can replay it, but I need my space to keep on going. So you recognize that I had x plus 8 squared from the box. So I now have x plus 8 squared equals 57 plus 64 is 121. Yeah? And then I'm going to bring it back to 0 because remember, vertex form looks like this. F of x is equal to a x squared plus k. So I'm going to go ahead and tell you now I recognize, so minus 121. Minus 121. I got to bring it back to that f of x equals 0, the equality in the back. So I now have my vertex form. F of x equals x plus 8 squared minus 121. So what does this tell me? This tells me that my vertex is f of negative 8. Remember, my input is always opposite of what the equation is telling me. Equals negative 121. So what I'm going to do is I'm going to go ahead and graph it on my calculator. I'm going to graph this guy, and I'm going to also see if that matches. So I have x squared plus 16x. And hold on, where's my button? 16x minus 57. And making sure my window has capacity. So I'm going to go negative 10, 8, 1, and negative 150, 50, 2 tens. So I'm going to showcase. Okay, if you can see my graph, see it has a nice parabola. So watch, there's my equation, x squared plus 16x minus 57, the one I started with. And then I push my graph and notice there's a parabola. And I'm going to hit my trace button and I'm going to go to negative 8. So trace negative 8, bam, negative 8, negative 121 from my y, right? So what is my vertex? Negative 8 is my input, and my output is negative 121. So I'm going to go ahead and show this all over again with another example. Please make sure you see this. So my next example is 6x squared minus 12x minus 21 equals negative 3. So first thing I'm going to do is I'm going to move this guy over here. Okay, so here I go. I'm going to add the 21. So I now have 6x squared minus 12x is equal to negative 3 plus 21 is 18. But remember I said I need to have ax squared has to be 1 for a. So right now I don't have that. So I got to do something. I'm going to use my division property of equality, which means I'm going to divide this guy by 6, but because this is an equation, if I divide this by 6, this guy has to be, everything has to be divided by 6, yes? So now my new equation says x squared minus 2x equals 3. Notice again, I left that space. So I am going to add something to both sides of the equation. So here I go. My ax squared will always go here. And now, again, remember that my box has to be perfect. So it's a perfect box because these two values here must add up to the negative 2x, but they have to be identical. So two values that when I add them together gives me negative 2x, and they are identical, negative 1x and negative 1x. Let's see, negative 1x plus negative 1x gives me negative 2x. Bomb. Okay, so now, what do these guys have in common? They have an x. X times what gives me x squared? X. X times what gives me negative 1x? Negative 1. X times what gives me negative 1x? Negative 1. Awesome. So negative 1 times negative 1 is a positive 1. This is the guy that gets added here. So I'm going to put a plus 1 here. Whatever I do to the left, I have to do to the left, to the right. Yes? Okay. So now, what is it that my box is telling me? My box is telling me that my polynomial now, I change this guy to factored form. I have x minus 1 and x minus 1. Remember, x minus 1 and times x minus 1 is really x minus 1 squared. So my equation, this guy right here, this whole thing, I can now rewrite it as x minus 1 squared because the box is showing me that this and this is equivalent to that. So x minus 1 squared is equal to 4. Again, move the 4 to the left, minus 4. So I now know that my function is x minus 1 squared minus 4, which means that my vertex is f of 1 equals negative 4. So let's see. I'm going to go ahead and use my calculator. Cancel that guy out. I'm going to have 6x squared. 6x squared minus 12x minus 18. I'm going to bring this over here. Calculator can only read standard form or factored form, right? And I'm going to go ahead. My window was tailored to the previous problem. So I'm going to go ahead and fix my window. So negative 10, 10, 1. Negative 10, 10, 1. And we're going to see where this function is at. So I think I messed up on my function equation here. Hold on. Negative 10, 10, 1. Oh, I might have to do a multiple of 6. Hold on. There we go. Negative 60, 60, 10. No. Hold on. Okay, I'm going to put this one here. 4. I know why. So, here it is. I'm going to go ahead and trace my minimum. So I have 1. Trace it with negative 24. That's right. My A is still 6. Remember this guy right here is 6. So that A gets to be applied to that K right there. So 6 times 4 is negative 24. So let's see. So I have a 6 here. Bloop. Right? So my vertex is f of 1 equals negative 24. So look at it there. And we're going to go ahead and now solve this. Okay. So now we get to solve. Okay. So solving quadratic equations. I know this is a long video, but it's important. So solving quadratic equations. when we're solving, the way that you're always going to set up your equation will always be set up in this format. Equation setup. F of x is equal to 0, okay? So f of x is always going to be equal to 0. Why? Because the solution to a quadratic equation is finding the x-intercepts, okay? So let's go ahead and look at an example. If I have f of x is equal to x squared minus 4, okay? I have multiple options, so watch. I'm going to let this equal to f of x is equal to 0. So I recognize that I have f of x is equal to x squared minus 4. I have to equal it to 0 right there. So now I'm going to solve. So by solving, I can use this way. Oop. I now have x squared is equal to 4. Okay. How do I undo a square? By taking its square root. Okay. By me taking a square root of this value, I now have two possible solutions. My two possible solutions are x is equal to 2 or x is equal to negative 2. Now let's look at this equation from a standpoint of a graphical representation. If I make a table of values for this guy, and I'm going to go negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay? So let's start with f of 0. F of 0 means 0 squared minus 4 gives me negative 4. F of 1, 1 squared is 1 minus 4 gives me negative 3. Okay, f of 2, 2 squared gives me 4, 4 minus 4 is 0. F of 3, 3 squared is 9, 9 minus 4 is 5. F of negative 1, negative 1 is squared is positive 1, 1 minus 4 is negative 3. Negative 2 squared is positive 4, 4 minus 4 is 0. Negative 3 squared is positive 9, 9 minus 4 is 5. So notice I made a table of values. I'm going to go ahead and now graph it, and I'll graph it over here. So negative 4 and x. So I'm going to graph this again, 0, negative 4 right there, 2, 0, negative 2, 0. So I want you to notice these guys. These are important. 3, 5. So 3, 5 is right there, negative 3, 5. So I just graphed, and I'm trying to do this as nicely as possible, my parabola. Notice that it's concave up because a is positive 1. This is in standard form, okay? And it's technically also in vertex form. So if I write this like this, it's telling me that f of 0 equals negative 4 is my vertex. And it is. It's my lowest point on my parabola. So I was able to find the solution by using the square method, right? The square root method. This is called the square root method. And I'm going to show you how to solve this multiple ways. So right now I solved it by the square root method, but sometimes when you have a b value in there, you can't use this method. So moving on, but I just wanted to show you x squared minus 4 is this parabola. I showcased the algebraic way to find that the 0 solution is negative 2 and 2 because those are my x-intercepts, my roots, my zeros. That's how I'm solving for this equation, okay? And now I'm going to go ahead and also recognize, let me erase that part. I'm going to also solve now for this guy. I'm going to go ahead and play the box and see how everything that we've done so far connects. So remember that this really is saying x squared plus 0x minus 4. A is equal to 1, B is equal to 0, C is equal to negative 4. So that's a 0 here. 1 times negative 4 is negative 4. Two numbers that when I add them up gives me 0, but when I multiply them gives me negative 4. That's a positive 2, negative 2. So here comes my box. Ax squared will always go here. My c goes here, and then I have a positive 2x and a minus 2x. So now I am playing the box, doing the backwards box, and I get x minus 2, x plus 2. But remember, when I'm solving quadratic equations, I have to let that equal to 0. So I now have two factors that when either one of them is 0, my solution will be correct, because 0 times any number is 0, or any number times 0 is 0. So I have two cases. This is called the case 1, case 2 scenario. Case 1, case 2. Okay? So the first thing I'm going to do is I'm going to let the first factor equal to 0. X minus 2 equals 0. And I'm going to solve. So I'm just going to solve. Plus 2. X equals 2. And then my case 2 is the second factor. I'm going to let that guy equal to 0. So then I'm going to solve. Did I still get the same answers that I got previously? I did. But I'm now using the factored form. So case 1, case 2, I was able to find the zeros. Okay. So let's go back and let's say I have a function that I would like to, let's go back to this guy. So I have, let's say I have x squared minus 6x plus 8. Okay, and I want to solve this. I want to solve it. So I'm going to show you how I can solve this by either factoring or by completing the square. Okay, I can't use the square root method because if I move the negative 8 over here, I still have these two guys, and I can't just square root both things. This guy doesn't have a square, so I can't square root. So the square root only works on certain situations, the square root method. So I'm going to have to factor, okay? I'm going to have to factor, and we're going to go ahead and see. So here I go. If I have to factor, what's my A? A equals 1, B equals negative 6, C equals 8. Okay, let's play the game. B plus AC dot. I got a negative 6, that's my B, and 1 times A gives me 8. So I need two numbers that when I add them together gives me negative 6, but when I multiply them gives me positive 8. So negative 4 and negative 2, let's see. Negative 4 plus negative 2 gives me negative 6, check. Negative 4 times negative 2 gives me positive 8, check. Awesome. So now I'm going to go ahead and make my box. So I have x squared always here, positive 8 here, and negative 4x and negative 2x go here. Remember, these guys will always have the variable of b. Now let's go ahead and figure out what that is. I have, what do these guys have in common? They have an x. X times what gives me x squared? X. X times what gives me negative 4x? Negative 4. X times what gives me negative 2x? Negative 2. And does this check out? Yes, it does. So I was able to find that I now have x minus 4 and x minus 2 equals 0. Okay, so I'm going to go into the case 1, case 2 scenario, which, just bring this, there we go. Case 1, x minus 4 equals 0. The first factor, let it equal to 0 and then solve for x. So I know that x is equal to 4. Cool. Case 2, x minus 2 equals 0. Solve for x. X equals 2. So this has two solutions, 4 and 2. So I'm going to see if that's true. Let's go ahead and graph it. So let me just make sure my window is valid. And I'm going to go ahead and x squared minus 6x plus 8. I'm going to graph it. Okay. And I'm going to zoom in. Okay. So here I am zooming in. I think I zoomed in too much. I'm going to zoom in closer to here. So I'm going to just do -2 on the min, and I'm going to do 8 over here, and I'm going to do -5 and 5 over here with a 0.5 scale. So let's see what we got. Oh, that's a nicer one. So let's go ahead and trace, and I'm going to put 4. What is the value at 4? It's 0. What is the value? Trace again. And what's the value at 2? It's 0. So my factoring did bring me those x-intercepts that give me the solutions to the quadratic. But I'm going to also showcase completing the square. So you can see, because your homework assignment for this is completing the square, solving equations by completing the square. So there's going to be problems that are saying solve the equation by factoring. Some of them will say solve the equation by square root method, and some will say solve the equation by completing the square. So very first thing I got to do is make sure A is 1. It is. I now need to move the C to the other side. So I have x squared. That's going to be to the other side like that. Boop. Minus 6x equals -8. Again, remember, completing the square means I'm going to add something here, and that something is whatever I get from creating that perfect box. And the reason it's a perfect square is because the binomial that I have here and here are identical, so it makes it a perfect square. So again, that goes here. Okay. Remember, the two values that I add up here, they get added, must equal this -6x, and they have to be identical. So what are those two values? -3x and -3x. Why? Because -3x plus -3x gives me -6x. Okay, now let's go ahead and see, what do these guys have in common? X squared and -3x have an x in common. X times what gives me x squared? X. X times what gives me -3x? -3. X times what gives me -3 right there. And I recognize -3 times -3 is a +9. This is what gets added here. So there's my +9. Okay, so now I now have, notice, x minus 3 and x minus 3. Instead of writing x squared minus 6x plus 9, I can write it in factored form, which is x minus 3 and x minus 3, which gives me x minus 3 squared, and -8 plus 9 is 1. Okay? So that's what I have so far. So let's go back, see my graph here. This is already, so I'm going to do a little side action because right now I'm going to also solve it, but I'm going to also come back and show you that this is still telling me vertex form. So let's go ahead and solve this. Now I have this entire quantity squared equals 1. So I can use now the square root method. Boom, boom, boom. Yes? So what do I have? I have the square and the 2 cancel. So I now have x minus 3 is equal to, and square root of 1 is going to give me +1 or -1. Okay? So this is going to give me two things. X minus 3 gives me +1, or x minus 3 gives me -1. Okay? So let's see. Now we're going to go ahead and solve this. So I have +3, x equals 4, and then over here, +3, -1 plus 3 gives me x equals 2. So let's go back and see, did it still give me the two solutions I had previously done through factoring? It did. So this is how we solve by completing the square. Now let's go back to this and let's see, what's my vertex? Remember, I have f of x is equal to x minus 3 squared, bring the 1 over again, -1, which means that my vertex is f of 3 equals -1. Let's see if that's true. Let's look to see. I'm going to trace to see what is the value at -1. And bam, my calculator has that point on the vertex, and that 3 corresponds to an output of -1. Okay, so recap. How do I solve equations of the quadratic equations? I let them equal to 0, and I have multiple processes that I can do. I can complete the square and use the square root method. I can factor and do case 1, case 2 scenario to figure that out. And I'm going to do quadratic formula for next week. So right now, your assignment will only be for solving quadratic equations by factoring, doing case 1, case 2, and by completing the square. So I hope you liked this video. See you guys. Miss you. Stay safe.